Hi, fourth grade. Your homework from Friday was to understand why clay settled downstream further than the sand would have. So we just talked about how water moves weathered pieces and soil pieces in landforms. Clay moves further because it's lighter, so it travels with the water and settles out further downstream. Today we're going to be talking about how floods affect erosion and deposition. Please make sure you have your science notebook and a pencil and come back when you're ready. In your science notebook, please write the focus question, how do floods affect erosion and deposition? And remember, erosion is the wearing away of soil and rock based or used with water or wind. Deposition is the moving of soil. So now you're writing your hypothesis. How do you think floods affect erosion and deposition? Okay, I want you to see that we are sitting at our stream table. Everything has been reset. And instead of using our standard water source, which would just be a regular rain, and using rain, you would notice that soil doesn't travel very far. It doesn't erode very quickly. It would take a long, long time for soil or rock to wear away. We're going to see what happens if we had the situation of a flood. Now, we are going to use our flood source, and the hole in the bottom is a little bigger, and I'm going to place it on I hope this doesn't gush out. I'm going to place it on our ruler, and we're going to see what happens to the soil when we have the conditions of a flood. I have the exact same amount of water, 1 liter, so that's again a control, and the variable is the size of the water, the size of the hole that's underneath where the water is coming out. As you can see, it's swirling. It's swirling pretty quickly. I have water pooling already. There's a crack that's formed in the dirt. Can you see how there's a crack that's formed in the dirt already? And the water is just filling up in the back of this tray. Do you see how the water is filling up in the back of this tray? Oh, all right, we've got water coming through. Oh, the dirt's already starting to fall. See how the dirt is falling? None of this happened last time. It's happening pretty quickly. I'll come above. This whole side, it's almost like a landslide. Because of the water, the entire part of the dirt is eroding away. So if you had a house, or if you had built on this side, your house is now, oh wow, watch how that stream just goes so quickly. And there's a big valley. We're cutting away through the sand. Oh, this side is starting to fall. So this is an example of how quickly soil or the side of a mountain could be taken out by water of a flood. Do you see the difference of the regular rain versus how quickly the soil eroded with the flood conditions? I'm going to zoom in again. Do you see how there's a big canyon on that side? How the soil traveled far. There's soil down in here, and it's still pooling. So this is the conditions of what would happen to the side of a hill, a mountain, or even a regular, just your regular dirt with the flood conditions of a flood. Please go ahead and get your science notes out. And what we just witnessed was that during a flood, earth materials eroded faster, moved farther, and formed a deeper valley called a canyon. The flood moves more earth material than your regular standard and slope stream tables because the mass of water has more energy than the smaller mass of rain. Now I'm going to show you some videos of floods. A flood is an event that can change the Earth's surface in a short period of time. It can erode and redeposit more rock material in 10 hours than a regular water flow can erode and deposit in 10 years. So that's how serious floods are. A flood could affect the soil that might take 10 years to move in 10 hours. That's how quick it could happen. So I'm going to share my screen and I want you to watch this video with us.
Over the past 100 years, no other natural disaster in the U.S. has caused more death and destruction than floods. They can happen any place, any day, any time. And they will likely only get worse. Water levels rise suddenly, far more than ground levels. Flash floods are a perfect example. Sudden storms unleash torrential downpour. The runoff moves with surprising force. At a depth of 2 feet, water can push aside a cloud. After all the deaths from flash floods. Heavy rains and blind snowfall overwhelm rivers. Storm surges caused by hurricanes and tsunamis inundate the coastline. Landslides and flood flows can displace large volumes of water. Dams break, levees fail. In the Great Mississippi Flood of 1998, several of these factors came into play. Over 10,000 square miles of the Midwestern United States were overwhelmed with rain. In a cruel twist, the earthen dams known as levees along the upper Mississippi River forced the water to flow downstream faster and stronger. Communities further downriver were hit with the full brunt of the Mississippi. All the levees, the towns rallied to protect their lives and livelihoods. At the start of this century, another powerful flood wreaked havoc, this one coming from the sea. The storm surges of Hurricane Katrina submerged 80% of the city of New Orleans. Over 1,800 people died in the floods. The damage has been estimated at over $80 billion. In some ways, the New Orleans disaster was unique. Much of the city lies below sea level, and despite years of warning, the city was woefully unprepared for the breach of the levees which kept it dry. But we are still vulnerable. Sea levels may rise, coastlines could erode, rain patterns might change, snowpacks could melt, and then the waters would rush in.
What we're going to talk about next when we come back tomorrow, we're going to talk about what kinds of events affect Earth quickly. So a flood could affect the Earth quickly, and it moves soil from place to place.
Whenever I ask my friends about the last time they went a whole day feeling...
Sorry about that technical difficulty, but tomorrow we'll be talking about landslides, volcanoes, earthquakes, and how quickly they can affect the Earth's surface.